the second topic of chapter structure of atom. Now let us have a glance about the content which we are going to study in today's class. So in today's class we are going to study about distribution of electrons in the orbits. How are electrons distributed in the orbits? So in that, let us first have an introduction. The distribution of electron in an atom or in the orbitals of an atom was proposed by Niels Bohr, and it was later on expanded by Gilbert and Lewis. Okay. Then what is the purpose of studying this electronic distribution? The purpose is it helps us seeing this electrons are arranged, and it also helps us to explain how an atom reacts, its reactivity and its chemical properties. Next, let us study about what are the rules followed by electrons. What are the rules followed by the electrons while you can say what are the rules followed by electrons while filling the orbitals. So first rule is number of electrons in an orbital, that is maximum number of electrons in an orbital. So to fill an orbital, we use a general formula 2n square, where n is the number of shell, that is 1, 2, 3, 4 and so on. The first shell is named as K shell, and it's for, if we substitute the value of n in this K shell with the formula using 2n square, we get 2 electrons. Second shell is L shell, 2 into 2 square is equals to 8 electrons. Third shell is M shell, and number of electrons is 18 electrons. Fourth shell is N shell, and number of electrons are 32 square. Now here we can see an example. Okay, here we can see an example. Example is sodium atom. Now sodium atom has 11 electrons. Okay, now its configuration is 2 electrons will be in K shell, 8 electrons will be in L shell, and the last 1 electron will be in M shell. Now next rule is maximum number of electrons present in the outermost shell. So outermost shell can hold up to 8 electrons. Example, you take neon. Neon has complete outermost shell with 8 electrons, making it chemically stable. Next rule is filling order. What is the order of filling? So here the order is electron fill inner shell before moving to outer shell. For example, you can see carbon. Carbon has 6 electrons. So its distribution is in 2 shell in K, 2 electrons in K shell. When K shell is completely filled, the remaining electron goes to the L shell. That the remaining 4 electron go to L shell. The next rule is atomic structure of first 18 elements. Here they give electronic configuration of first 18 elements of periodic table. You can see the diagram here, children. I will expel you here with a color. Now you can see this is hydrogen. Hydrogen has 1 electron. So distribution of electron, then helium, then lithium, beryllium, boron, carbon, nitrogen, oxygen and so on. So this is the distribution. This is the way how electrons are distributed in the orbitals. There. Now let us see the models, how actually distribution is done. Now you can see here it is an parking station. You can see here how cars are parked in the station. I am showing you the parking station of the car. The parking station is in the form of multiple levels. First level, second level and third level. So we can compare the electrons to that of car, okay, and the levels of parking as that of electron shells. So here, if you see, if we compare these electrons, if suppose you compare these cars as electrons, okay, and this multiple levels or the parking levels as electron shells. Okay. Now this was an example. Let us see how electrons are distributed, okay, in the orbitals. Now you can see here this is an orbital, right? Now this is center is the nucleus, okay. This center is the nucleus, and this is first orbit, and this is second orbit. This green which you are seeing are the electrons, right? Now we will see how the distribution of electrons takes place in an orbital. You can see here the first shell, okay. The first shell has been filled by 2 electrons. Just now we said no, the first shell is K shell, second shell is L shell. So first shell has been filled with 2 electrons. Its capacity is only 2 electrons. So it has been filled. Then the remaining electron goes to next shell. Now next shell, its accommodation is 8 electrons. So you can see 1, 2, 3, 4, 5, 6, 7 and 8. So like this you will see the filling of electrons in the shells. Okay. Then you can see electrons are filled in the shell, right? Now let us go back to arrangement of electrons. Now here you can see the orbitals. Okay. Here you can see the orbitals. Center is the nucleus, right? I explained you before also. Center is the nucleus. Then you have N shell. N is equals to 1, which is K shell, right? K, L, M, N shells. So K shell is the value of N is equals to 1. Then N is equals to 2 for L shell, right? In the same way, N is equals to 3 for M shell. N is equals to 4 for N shell. Like this, you will see arrangement of electrons in the different shells. Then, if we see arrangement of electron, arrangement of electron, just now we studied, no, arrangement of electron is through by using a formula 2n square. So here n value if we substitute, you will be knowing about in each shell how many electrons are present. Okay. So if you substitute the value of n is equals to 1. Here you can see n is equals to 1 we substituted. Alright. Here we substituted n is equals to 1. So K can accommodate 2 electrons. Likewise, if suppose we substitute the value of n in each orbitals. For example, here the value of n is 2. So, and here the value of 3, n is 3. Here the value of n is 4. So like that, K, L, M, N shells will accommodate different number of electrons. So K shell can accommodate 2 electrons. Then L shell can accommodate 8 electrons. Then M shell can accommodate 18 electrons. Then N shell can accommodate 13 electrons. Okay. Now let us check our understanding whether we followed the content. So here are some questions. What is the first question? What is the maximum number of electrons that can be accommodated in the outermost orbit of an atom? Answer is 8. Next question. Which scientist suggested the distribution of electrons into different orbits of an atom? Yes, the answer is Bohr and Barry. So likewise, we have many more questions which I will be sending you as homework. Kindly go through it. Till then, take care. Bye.